So let's explore solution techniques to parabolic partial differential equations with a problem. Okay, so here's our problem. Suppose we have two plates separated by 10 centimeters, and between the two plates we have oil and water. So let's sketch this up. Okay, so here's our top plate. And our bottom plate. Okay, and we have two fluids inside here. So at the top we have oil, and at the bottom we have water. Okay, so let's just denote this as O for oil, W for water. And they're separated by a distance of 10 centimeters. So X is going to be in this direction. So X equals 0 and 2, 4. The interface is at 6 centimeters, 8, 10. Okay. Now I've drawn this long in this direction, which let's just label that Y. And the reason for that is just to give you an idea of how the problem looks in real life, because you wouldn't just have a single slice in this direction, but of our problem. Okay, so there's some important governing equations here. So firstly, we have that the rate of change of the velocity, let's say of oil with time, is equal to mu naught mu of oil and the second derivative of the velocity, x squared, and the set is the same for water, equals mu of water day squared v of water day x squared. Okay, and now our problem in itself is a little bit vague, so let's add some more information. Well, let's say at time 0, so time equals 0, the top plate is moved at 8 centimeters per second, at constant speed. Okay, and the acceleration to 8 centimeters per second happens so rapidly that it appears as if this top plate is moving at a constant speed of 8 centimeters per second. Okay, so at the interface, we have the velocity of the oil must equal to the velocity of the water. And we have the following, the shear stress is also equal. So the shear stress in the velocity is the same as the water. So there's conservation of the shear stress across that interface. Shear stress from first year fluids is written as mu of oil times the velocity gradient, and that's equal to mu of water multiplied by our velocity gradient of the water. Okay, and the dynamic viscosity of oil is 3, and the dynamic viscosity of water is 1. Okay, and we want to calculate the velocity at time equals 0.5, 1 and 1.5 seconds, for the distance, the x values of 2, 4, 6, 8, and 10. Alright, so before we're going to use Excel to solve this problem, and before we do that, I'd like you to think about what is the value of lambda that you're going to use, or say delta t, your time step, and think about your boundary conditions. What are the boundary conditions that are important for this problem?